So here we go. If I'm looking at our old furry friend, again, y equals x squared, that's our basic function. If I'm looking at just graphing straight out, y equals x plus 2 the quantity squared, I start at -2, -1, 0, 1, and 2. And just plug in -2, I get -2 plus 2 quantity squared, I get 0. -1, -1 plus 2 is 1 squared, I get 1. 0, 0 plus 2 squared, I get 4, and so on. And then I just graph this guy, and -2 is, it's x equals -2, y equals 0. If x equals -1, y equals +1. If x equals 0, y equals 4. If x equals 1, y equals 9. Now I'm off my graph paper. Now if I go to graph it, you notice I'm only getting half of this guy. He really is going to turn around and go back up. That's the downside of trying to graph this thing using the normal T-bar chart, because you don't get the whole graph. You don't get the whole graph. But more importantly for us, I notice that this has been moved to the left by 2 units. And what was this? This was x plus 2 the quantity squared. So if I were to look at this, this would be x minus a -2 squared. That's where you get the left, because h is -2. That means left 2. Now what about the other side, x minus 2 the quantity squared? Well, I do the same thing, and now I'm going to graph this guy. If x equals -2, y equals 16, so I'm way off my graph paper, and at -1, it's 9, so it's up here someplace. At 0, it's 4. At 1, it's 1. And at 2, it's 0. And again, I don't get this whole graph. This guy actually turns around and goes back up. And that is the downside of trying to do this thing using a T-bar chart. You have to graph a lot of points to get a complete graph. What I do notice is that if I look, the basic graph, because remember this guy is basic, has been shifted to the right by 2 units. And that's where you're going to see, if I'm looking at x minus 2 squared, this is x minus a plus 2 squared, so h is 2. And that's where you're going to get the fact that it is going to be right by 2 units. So from the graph, the impact of f of x equals x plus 2 the quantity squared is this becomes x minus a minus 2 squared, which means it is left 2 units. And x minus 2 the quantity squared would be x minus a plus 2 squared, which means it's right 2 units. So the transformation is going to be of the form f of x minus h. And it's going to be performed by taking h and adding it to all of the x values. So if h is negative, it's going to act like a subtraction. If h is positive, it acts like an addition. So let's try the transformation. We want to graph f of x equals x minus 3, the quantity cubed, with the basic function being y equals x cubed. The transformation is, this is x minus a plus 3 cubed. So h is 3. So h is positive. The transformation is right 3 units. That means it's going to take all of the x values and add 3 because I'm moving right 3. So if I take a look at the basic function, it's y equals x cubed. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Now, because I'm going to be manipulating the x's, I'm on the x side of my t-bar chart. And what am I going to do? I'm going to add 3 to the x's. So this then becomes 1, 2, 3, 4, 5, and the outside is always my new graph. So if x equals 1, y is negative 8, so that's off my graph paper. If x equals 2, 1, y is negative 8. If x equals 2, y equals negative 1. If x equals 3, y equals 0. If x equals 4, y equals 1. If x equals 5, I'm off my graph paper, y equals 8. So here's my S curve. That's my new graph, y equals x plus 3, or x minus 3, excuse me. Let's clean this up a little bit. X minus 3, the quantity cubed. If I were to place on top of this the basic graph, the basic is not the red stuff. This is at negative 2. I'm down here at negative 8. At negative 1, I'm at negative 1. At 0, I'm at 0. At 1, I am 1. At 2, I'm at positive 8. And so here's your basic graph. And you notice this has been moved to the right 3 units. So our transformation is right on.